And welcome everybody to our Fields and Features segment. Regular feature here at the Smash News Network, Least Busted Name and News. It's typically our daily space weather video 2 of 3. This one is a live, not a live, this is a recorded YouTube exclusive. So the first thing we're looking at are the last 4 hours of magnetohydrodynamic pressure, looking at Earth's magnetic moment from space. Based on the space weather modeling framework, you're looking at nanopascals modeled here. Again, it's over the last 4 hours. We're seeing a subsiding of a coronal mass ejection strike. So as Earth's plasmaspheres and the magnetic environment around the planet attempt to reach static equilibrium, we're seeing the pressure subsiding here a bit. You can expect to see that continue throughout the day today. Here are ground magnetic perturbations, Earth's magnetic moment from the ground level. This model is in nanotesla magnetic flux density. And we expect to see quite a few auroral movies and photos. We will share them on our Twitter when we see them in our feed. Twitter at Smashomash. And we see the subsiding of ground magnetic perturbations as well. Some big spiky sawtooth readings here in the GOES magnetometers as a bunch of plasma has arrived, as forecasted. And we covered it quite promptly right after the coronal mass ejection happened. Next, we'll look at the heliospheric current sheet to see if there are any changes coming our way. And we can expect to see quite a bit of activity in the northern hemisphere of the sun. We've already seen another sunspot rise. We'll get to that momentarily. Earth remains in a south pole current sheet shown here in red. There's the north pole shown in green. How about a line of sight view? And there's a line of sight view. Colorized magnetogram coming up in our bonus feature segment. Make sure you tune into that. You can find additional content at twitch.tv/Smashomash, twitch.tv/Smashomash. We've got some serious South Pole-oriented coronal holes here reaching well up into the northern hemisphere, well beyond the equator, and some new North Pole-oriented coronal holes rotating in as well. That's the line of sight coronal hole plot showing the sun's B field as those blue lines there. And here's a view of 193 angstroms. Great SDO imagery there. And you can see some definition of those coronal holes. Still some indication of the south solar polar coronal hole, as the solar polar field reversal process has been taking its time throughout solar cycle 25. Let's move on to sunspots. Quite a few named groups here, at least 8 named groups, and we're about to get at least one more up here. This will be 2967, it looks like, and possibly 2968 down here in the southeast. Likelihood of major flares very high, folks, very high. I would say especially from, well, frankly, 2964, but especially 2965. It's very complex, it's very compact, it's got complex fields. Three large distinct umbra there in the leading zone, one large distinct trailing umbra. It's a very spotty sun, folks. And solar cycle 25 turning out to be quite active indeed. Is it a grand solar maximum? Let us know in the comments if you think it's a grand solar maximum. Check out those spots. Those are capable of producing large flares too, folks. We've got a whole bunch of areas where we can expect to see things happening. You see some activity rising here in the southeast. Here's the northern hemisphere, and we will show you a zoom in of Sunspot 2965, our current star of the star. Check it out. That is a serious sunspot. And we see some flaring and coronal mass ejection from down here. Make sure you check out our live stream from yesterday. It's titled, OMG, we're all gonna die. We're all gonna die. So we did see a long-duration C-class flare. That sent some relativistic particles our way. We saw a brief period of polar high-frequency radio blackout. We'll show that next. That's the GOES X-ray flux over the past 3 days, and we're approaching background C-class levels where we're just at a C-class X-ray output without even seeing flares. That's a very long duration flare there. The peak flux was around 2030 universal time last night. So here's your proton event. You can see these relativistic particles showing up. Peak flux there was around 730. And if you look at the deabsorption regions there, some major significant radio blackouts there as some relativistic particles arrived at planet Earth. So there was a C-class flare. So it only took about an hour for those to arrive. Those particles moving at about 1/8 of light speed. Hence the term relativistic particles. So there's your radio blackouts. And those were low enough levels that they look like they're not expected to have continued here. We did see some polar radio blackouts there in the Arctic regions from relativistic particles. Make sure you watch our previous video, twitch.tv/smashamash. We talked about cosmic ray flux. Next, looking at the real-time solar wind, and here's the arrival of the coronal mass ejection. You can see a bunch of signals all change here at the same time. Plasma temperature, check, an uptick in the density and the speed at the same time. Shift in the phi angle and shifts in the BT/BZ. We saw a pretty strong field at this moment. It got up to about 17 nanotesla there. 18 nanotesla with a northward BZ of 12. And this is when things got a little jiggy here. We saw a fairly powerful series of negative BZ moments, which created some geomagnetic unrest. Peak density was about 32 protons per cubic centimeter. Peak speed, not so high, but it made a great signal there as we had a very slow diffuse coronal solar wind to show us a good signal there. Current conditions are largely subsided here, back to about 400 kilometers per second for the solar wind speed. Solar wind density still a little bit elevated here at 16.2 protons per cubic centimeter. Moving on to look at the KP index, a measurement of global geomagnetism. NOAA was expecting a KP5 early this morning, but it never quite happened. And it all had to do with the magnetic field shifting, so we did see about 3 hour long periods here of geomagnetic unrest. A perfect example of sort of a glancing blow, a CME that didn't strike Earth directly. The one we covered last night is going to strike a little more directly, so we may see a significant geomagnetic storm from that. Next, we'll look at the planets. Here's a solar system forecast. There's where things will be in a week. It looks like it'll be a full moon on around the 18th there. That's your 1 week forecast for the solar system. Here's what's going on above my head in Lehigh Valley, Pennsylvania. We've got Venus and Mars next to each other, Saturn and Mercury and Jupiter all rising ahead of the sun. A bunch of planets showing up in the morning sky. It's a great day to have a low horizon and clear skies. Next, some coronagraphs, and we've paused this here because this is the moment when some relativistic particles have struck stereo A. So that's the coronal mass ejection we covered last night, and check out the size of this one. A bunch of that plasma is headed straight down the earthly pipe, and Earth would be off in this direction from stereo A's perspective. It will be behind you from the perspective of the Soho-Lasco C3 pictured here on the right. So, there you can see relativistic particles striking stereo A. That was a C-class flare, that long-duration flare that we covered earlier. And here's your halo eruption. That CME headed quite directly toward planet Earth in a large part. So most of the ejecta is actually off to the north, but there's a huge portion of it headed toward Earth, and it's pretty dense, as you can see in this imagery here. Pretty dense CME there. I would expect geomagnetic storms in a little under 3 days from that. Again, stereo A is located here at Lagrange point 5, trailing the Earth orbitally speaking, seeing space weather ahead, hence the term stereo A. At Lagrange point 1, that's where you have your Lasco Soho C3. Thanks for tuning into our Fields and Features segment. Please press like and subscribe if you enjoy the content. Help us out that way. Consider becoming a member of the Smash Team at smashamash.com/SmashTeam. Help us to Mensa, make Earth not suck again here at the Smash News Network. Least busted name and news, and may that solar wind be at your back.